In question number 5, we'll go backwards from what we were doing in number 4. By giving us a log expression, they're going to ask us to write it as an exponential. So hopefully you can start to kind of see the connection that logs and exponentials go together. Namely that log is the opposite of an exponential and that exponential is the opposite of a log. So being able to switch back and forth from one to the other form is going to be a really big skill that we want to make sure we understand and practice before we try to go any further in understanding what a log really does for us. So in question number 5, let's start with rewriting it as an exponential. Normally I would say, oh, let's solve for x first, but in a log expression, x is not really very clear, and I think it might make more sense to actually start with the exponential form. This is where that little arrow that we were doing could come in handy. If you're color coding, that's fine too. You can certainly do this in whatever way you want. But hopefully by now you've seen enough of these that you can start to remember the order in which this log translates to an exponential. Namely that the log base, the subscript, 2, to the power of whatever's on the opposite side, 2, is equal to whatever value is in the middle, the thing attached to the log and its base, which is the x. Then, of course, once it's in exponential form, we can say, oh, okay, of course. Now our brain kicks in and we go, oh, 2 to the power of 2, that's 4. So we can solve for x much more easily in exponential form than in log form, and it's totally fine to do the problems in that order. Exponential form first, then solve for x. Hopefully, once you start to see this, you'll find it a little easier than going the other way. Many people find it challenging to write exponentials as logs, but not so challenging to write logs as exponentials. And I think it's because that little visual pattern there with an arrow or whatever helps you connect the numbers is so consistent. It's easy to start to see that relationship take place. So in this letter B example, subscript of x, so that's our base, to the power of whatever's on the opposite side, which is 3, is equal to whatever number was attached to the log in the first place, which is 27. X cubed equals 27, so that means x must be 3, because 3 times 3 times 3 is 27. Another one, just so you can see the consistency here, use the arrow if it helps, use any visual pattern that helps. And now the base is always the kickstarter here, so the base of the exponential will be 5. To the power of whatever's on the opposite side, so power of x equals the number attached to the log in its base, 125. This time I have to think about it a little bit. 5 to the power of something is 125. That means 5 times 5 times 5 times 5, however many times, gives me 125 as an answer. You can use guess and check, you can use a calculator, you can use mental math, whatever you like to use, but x would definitely need to be 3, because 5 times 5 times 5, 3 times, is 125. One more just so you can see that this goes a little bit expeditiously once you get the pattern. 6 as the subscript or the base to the power of whatever's on the opposite side, there's your 1, equals whatever's attached in the middle, so x. 6 to the power of 1, of course, is 6. So some of these exponential expressions are pretty easy to do comparatively. Now that you've seen the pattern take shape, now that you hopefully have a pretty solid foundation in the relationship among the numbers in a log expression, try letters E through H. Try to make those connections clear to yourself. If you have any questions, of course, consult the answer key first and see if that helps clear things up. If even after the answer key you're still not sure, I would actually pause, stop watching this, and ask a question. Email me or join in the next Zoom and try to get some more foundational knowledge before you attempt to go on to 6, 7, and 8. 6, 7, and 8 tend to take a bigger picture approach, as in like, why would we even learn logs in the first place? So it's crucial that we understand everything up through 5 before we jump into 6.